remembering various kinds of information and forget some things and replace it by something else based on the new input. So these are done by gates. So let us talk about gate, what the gates do. So the gate, a typical gate looks like this in the LSTM schematics. Information comes, typically it goes through a non-linearity layer, sigmoidal layer, take the logistic function, the output will be in the range 0 to 1. Suppose the information that comes through is a lot of information, 10 types of information is there. When information comes, 10 pieces of information come, 10-dimensional vector, let's say. When it goes through the sigmoidal function, sigmoidal layer will give rise to 10 numbers. All these numbers will be between 0 and 1. At this point, the information that is there gets pointwise multiplied by this vector. Let's say there are 10 values here, and they get multiplied by the corresponding 10 numbers. Each of them are between 0 and 1. Let's say the number here is 3, 4 and -2, something, and the numbers here is 0, 0.5 and 1.0, just for arguments. This x tells that it is a pointwise operation. It is a kind of dot product. So you multiply 0 with 3, it says that information 3 came in, but don't remember it, forget it. The information -2, remember it as it is important. Information, the second information, you remember part of it only you remember. So the gate tells what percentage of the input that is coming in should go through. It is like our security gate, a student pass through. A stranger, don't let him pass through. A visitor, go through some process and then pass through. Gates control the amount of information that goes through via pointwise operation. Here, if we have to sigmoid, use the logistic function. If you use the time hyperbolic function, the output could be in the range -1 to +1. What is the meaning of the -1? Suppose the fourth number is -0.7 and this number is, let's say, 7. So when you multiply 7 by -0.7, the output that goes through here is a negative number. It tells that if information that there is a negative correlation between the information, this fourth information. So if this is positive, remember it as a negative. So different types of activation functions through the gates help us to remember the extent to which the incoming information needs to be passed. Now let us go through each of the gates. We talked about forget gate, input gate, output gate and current state. Okay, these are the 4 layers that are interacting. These 3 gates we will talk one by one. Let's first talk about the forget gate. At time instant t, input comes xt, and this cell also remembers its hidden state ht at time t minus 1. These two together are combined. When you say combined, this gets multiplied by a matrix. Xt gets multiplied by a matrix, weight matrix, and this weight matrix is called WF for forget gate. Similarly, ht minus 1 is also multiplied by the weight matrix of the forget gate, WF. And then there is a bias of the forget gate, that's okay. And it passes through a sigmoidal function. So f at time instant t determines the amount of information that needs to be forgotten based on its state at previous time instant and current input. So this is the equation for the forget gate layer. There is a pointwise operation here, we will come to that later. Next is input gate. So one gate is over, now another gate. The input gate I at time instant t depends again on the current input and the state of the cell at previous time instance. So current input, state of the cell at the previous time instant gets multiplied by the weight matrix corresponding to the input gate. This W is different, passes through a sigmoid function. In addition, there is another function here, which takes in the same input at time instant t, that is here, and the state of the cell at previous time instant ht minus 1, multiplied by another weight matrix. This is to do with the cell state, that's a WC, subscript C, and bias, passes through a time hyperbolic function. This sigmoid function gives the output will be between 0 to 1, the time hyperbolic output would be between -1 and +1. This is a candidate for the cell state capital C at time instant t. It is candidate, so there is a tilde here. So IT comes here, tilde comes here, they get multiplied pointwise to get to the current state. So let us look at the current state. Previous state is there, it comes like this. It's like a conveyor belt. It comes like this. The cell state at time instant t minus 1 get pointwise multiplied by forget gate. So forget gate is the output here, and that gets pointwise multiplied. This is a gate. It gets multiplied. So information which was stored in the cell in the previous time gets selectively altered by the forget gate, selectively erased by the forget gate. And then, depending upon the new input that came here, the input IT and the candidate cell state C tilde T, they get pointwise multiplied to generate the state of the cell at time instant T. Previous one got forgotten partially, and the new information get added, and the current state of the cell gets updated. Now the last one is the output layer. This is the output of the neuron at time instant T. The updated C is here, it comes here. So the output depends again on the input and the previous time instant. So the current input at the current time instant and the previous output at t minus 1, it gets multiplied by the weight matrix W corresponding to the output gate, passes through a sigmoid function here, this is bias here, and it generates the current tentative output of the state, and that gets multiplied the pointwise multiplication here by the current state of the cell, which again passes through a non-linearity time hyperbolic function and gets multiplied, and output ht is generated. This output, this arrow is downwards here and upwards here, it goes out of the neuron. Not only does it go out of the neuron, the output is passed on for the next time instant. So you saw that 3 gates here. One is a forget gate. It tells how much information should we forget from the existing memory. And the next one is the input gate. How much of the input should be used to update the current state? The current state is updated by the input and the forget factor. And depending upon the current state of the cell and the inputs here, which is the so-called intermediate output of the cell, the total output of the cell ht at time instant t is computed. The advantage with this is that in addition to be able to the output ht depending upon not just xt but also on ht minus 1 and forget factor. Depending upon the situation, important things that gets retained, sometimes things get updated, and therefore it is able to remember relevant things that occurred in distant past, not just the short term memory. So that is the brief introduction to the long short-term memory. There are variants of this which uses what is known as a peephole connection. You know what a peephole is. Door is slightly ajar, you just look at what is happening inside. A small window, you get a view of the thing. So target gate not only depends upon the input at current time instant and the output at the previous time instant, but also on the state of the cell at previous time instance. So it is able to peep through, even the forget guy is able to peep through the information here, which come through. So that is one variant of LSTM. This occurs for all the three gates. Note down here, the output depends on the current state of the cell also. There is another variant of the LSTM which is the so-called coupled gates. The current state depends not only on the forget factor with respect to the cell state at the previous time instant and 1 minus of t of the current candidate for the state of the cell at current time instant. So various such variants are there. The last one here is called gated recurrent unit. Gated recurrent unit. So you see the number of connections have slightly increased. It combines the forget gate and input gates in some complicated manner, and it also merges the cell state and output gate in some manner. The number of some of the gates reduced, so it is a simplified version, and that has become more popular in the recent past. So these are some of the references from where some of these slides were taken. So in summary, the long short-term memory overcomes one main drawback of the recurrent neural network, that is RNN's inability to remember distant history. LSTM is able to, through its mechanism of forget gates, input gate and output gate and cell state, it is able to remember. If you are given a large amount of training data, it is able to remember what is relevant and when to replace it using the training data. And therefore, it does a better job of doing its task during the actual execution of the testing.